Hello, this is Mrs. Sargent, and this is lesson 7.4, Limiting Reactants. So a limiting reactant is the reactant that's going to be used up first. Once it's used up, the reaction is going to stop. This is going to produce a smaller amount of product based off of your stoichiometry calculations. The excess reactant is the reactant that is not used up, and there's going to be some of this left over. This is going to produce the larger amount of product when you do your stoichiometry calculations. So if we take a look up here at our diagram, we have hydrogen gas and nitrogen gas are reacting, and they're going to produce ammonia, NH3. So after the reaction goes, we have nitrogen gas left over. Nitrogen is going to be the excess reactant. The hydrogen gas is all used up, so this is our limiting reactant. Also, if you remember back to when we did our s'more stoichiometry, and I had a problem that I asked you guys to calculate how many s'mores can be produced from 16 graham crackers and 10 marshmallows. And you should have determined that you could produce 10 s'mores off of the 10 marshmallows and 8 s'mores off of the 16 graham crackers. So the graham crackers were the limiting reactant. The marshmallows were the excess reactant in that case. So how to solve limiting reactant problems? The first thing that you're going to do is you're going to do your stoichiometry calculations for each reactant to the same product. These calculations are nothing different than the calculations we've already been working with, only now you are going to have two problems, and in the question you're going to be given two numbers and units. Given and each of those numbers and units are going to start off a different calculation. And the second thing is that the reactant that produced the least amount of product is your limiting reactant. So after you've done your calculations, whichever one produces the least amount of product is the limiting reactant. The limiting reactant determines the maximum amount of product formed, and we're going to refer to this later on as our theoretical yield. And then the reactant that produced the most product after you do your stoichiometry calculations is going to be the excess reactant. There's going to be some of this left over after the reaction stops. Excuse me. So our first problem here, it says what mass of hydrochloric acid is formed when 3.5 grams of hydrogen reacts with 15.1 grams of chlorine. So here's one number in unit, 3.5 grams of hydrogen, and our second number in unit is 15.1 grams of chlorine. So each of these are going to start off one of our calculations. And we're going to do these to determine the mass of hydrochloric acid that can be produced. So if we have 3.5 grams of hydrogen, anytime we have a mass, we have to calculate the molar mass. Well, for hydrogen, hydrogen's average atomic mass is 1.01. There's 2 atoms, so we're going to multiply that by 2. And that's going to give us 2.02 grams per mole. So we're going to put 2.02 on the bottom to cancel out our grams of hydrogen. 1 mole of hydrogen on the top. And then we're going to need our mole to mole ratio between hydrogen and hydrochloric acid. So we're going to look at our chemical equation. We have 1 mole of hydrogen and 2 moles of hydrochloric acid. But we want the mass, so we need to determine the mass of hydrochloric acid. Well, hydrogen is 1.01, and we have one of those. Chlorine is 35.45. When we add these together, since we have one of each of them, we can just add them together. We're going to get 36.46 grams per mole. So we're going to put 36.46 grams of HCl over 1 mole of HCl. Take a look back. Your units should all cancel besides grams of hydrochloric acid. They do, so we're going to be left with grams of HCl. So we're going to take 3.50 times 2 times 36.46, divide that by 2.02, and you should get 126.3 grams of HCl. So now we're going to do the same thing, only we're going to use chlorine as the reactant to start off this calculation. So we need to determine the molar mass of chlorine gas. Well, chlorine's average atomic mass is 35.45. We have 2 atoms, so we're going to multiply that by 2, and we're going to get 70.90 grams per mole. So we're going to put 70.90 grams of chlorine here on the bottom. Look at the chemical equation. We have 1 mole of chlorine. We have 2 moles of hydrochloric acid. Oh, and we need to use our molar mass yet again for hydrochloric acid to find the mass. So it's still going to be 36.46 grams per mole. So we're going to take 15.1 times 2 times 36.46, divide that by 70.90, and I got 15.33 grams of HCl. All of these units do cancel. Okay, so now we can answer these questions. What is the limiting reactant? Well, if you remember, we said that the limiting reactant is the reactant that produced the least amount of product. So if we take a look here, that is our chlorine. So chlorine is the limiting reactant, so that means that hydrogen has to be the excess reactant. So how many grams of hydrochloric acid are produced? Well, we also said that the limiting reactant determines the maximum amount of product formed. So we're going to take the 15.53 or 15.33 grams of hydrochloric acid from chlorine, which is our limiting reactant. Okay. So take a look at this next problem here. I ask how many moles of CO2 are formed when 27.8 grams, or 27.8 grams of oxygen reacts with 15.7 grams of methane. I'd like you to pause the video and try to set this one up on your own. Welcome back. So we're going to start one of our calculations off with 27.8 grams of oxygen, and our other with 15.7 grams of CH4. So oxygen's molar mass, the average atomic mass is 16. There's 2 atoms, so that's going to give us 32 grams per mole. Look at the chemical equation to get our mole-to-mole ratio. Well, we have 2 moles of oxygen, and we have 1 mole of carbon dioxide. So grams of O2 cancel, moles of O2 cancel. We're going to be left with moles of CO2. So we're going to take 27.8 divided by 32 times 2, which should give you 126. Sorry, I'm looking at the wrong problem. Did that in the last video too. Should give us 0.4344 moles of CO2. Then if we take a look at our second calculation here, we're going to need to determine the molar mass of CH4. So carbon is 12.01 times 1. Hydrogen, we have 1.01 times 4. When we add these together, we should get 16.05 grams per mole. So we're going to put 16.05 grams of CH4 on the bottom, 1 mole of CH4 on the top. In our chemical equation, we have 1 mole of CH4 and we have 1 mole of CO2. So grams of CH4 cancel, moles of CH4 cancel. We're left with moles of CO2. 15.7 to 0.9782 moles of CO2. So our limiting reactant is going to be oxygen because it produced the least amount. And so our excess reactant is CH4. So the moles of CO2 produced is 0.4344 moles of CO2. Okay. You have practice problems on pages 12 and 13, all the practice for the limiting reactants. There is no book assignment today. There will be a lab next class, as well as a homework quiz over limiting reactants. So you want to make sure that you have worked through those practice before next class. Thanks for stopping by. If you have any questions, feel free to come and see me. Have a great day.